Hey everybody, and welcome back. This is Randy Bordeaux, and this is Tech Talks. So we're going to jump into Azure Kubernetes Service today. So we're going to kind of go through it and see where we get. So I will share this out so you guys can see the cool little screen here. All right. So before we get started, references, Microsoft documentation. Anytime you have questions, great resource. These are some of the links that I use to get to them. Basically, docs.microsoft.com. And you can also visit the Architecture Center, right? And if you don't want to copy these, or you don't have links to them, you can just Google Azure Architecture Center and it'll pop up and you can look up sample architectures for all this stuff. So our next thing. So Azure Kubernetes Service is basically this automated open source thing that people are using, developers specifically, to be able to push out applications in a way that automates a lot of the work, right? So this simplifies deploying the managed Kubernetes clusters in Azure and moves that overhead. Instead of having to build the master Kubernetes servers and all this kind of stuff, you just move that into Azure and then it's taken care of for you, right? And this gives you some different little tricks you can do. Azure handles a lot of the critical stuff, the health monitoring, maintenance, those kind of things. So you don't have to worry about it. And since Kubernetes, since the masters are managed by Azure, you only have to worry about your nodes, your pods, containers, that kind of stuff. So as we move through this, we're going to kind of take a look at different pieces of that. So when you deploy the cluster, right, there's a control plane, and then there's a master Kubernetes server, and that's above everything we see. And then below that are all the nodes, and that's what we get, right? As an Azure administrator, you're going to log in, you're going to be able to see your cluster, which is kind of a platform as a service, right? Because everything making that is handled by Azure. And then you're going to see the nodes, which is infrastructure as a service, right? And we'll get into what all this stuff is, right? So it does allow you advanced networking, AD integration, monitoring, some of the cool features you're used to with Azure. So for application development, they're moving towards this containerized approach, where instead of having server, you just have a container, which is essentially all of the resources you need in order to make this work, right? But if something happens, you just make a new container and then deploy everything out to it. It's all scripted, so you don't really have to worry about much. You don't have that hassle of having to create a server and load it and patch it and install your applications and all this. You already have the server and you're just creating a container that's on that server. So Kubernetes is the leading platform. It's what everybody's using. It's on AWS, it's on Azure, right? You can even run it in VMware, right? You can run it on your individual workstation if you want. It doesn't give you as much benefit there. So it just acts to simplify this process. So what is Kubernetes? Rapidly evolving platform, manages those container-based applications, the networking, the components, okay? It gives this declarative approach to deployments because you have all these APIs, management operations running in the background. So you can build, you can modernize, and make these portable and run what they call microservice-based applications that are benefiting from that. So you'll have these individual microservices that do individual tasks, right, for your application. And then you can run them as stateful or stateless, right? Maybe you don't need a node. Maybe you just need this service to run, right? So that's kind of where it is. And you start focusing on the workloads, the applications, right? Because the workload may be a full application. It may be a single function in that application. And that's where the devs come in. They write the code and then push it out to this. This is going to be about infrastructure, how we make that work. So our next piece, it's open platform, you can build, use whatever language you want, right? That's the whole theory of it, right? Is you don't have to conform and start using PowerShell if you know Python, right? If you can write your application in Python, write it in Python, throw it in a container, you got everything you need, right? So you don't have to worry about that. So the other piece is this continuous integration, continuous deployment tools, right? You can integrate those into Kubernetes. And Azure has their own mix, which is Azure DevOps. They have a CI pipeline service that you can use that ties into this, and you can integrate GitHub, or you could use something like Jenkins, right? That would actually go in and talk to this. So there's a couple different options. So AKS provides the managed Kubernetes service. It reduces this complexity. So instead of having to perform all these functions, Azure is taking that service, scripting it out. So when you click the button, it executes that script based on your parameters that you input, right? Everything in Azure ends up as a JSON, right? So you can actually look and see that. As you go through and you build your cluster, just export that template and you can see everything that it's doing. Now, the control plane, that's the piece where you have your API server, right? And that's the piece where Azure starts taking care of things, okay? Control plane's managed by the Azure platform. So really all you have to worry about is the nodes. So the AKS, the Azure Kubernetes Service, is actually a free service provided by Azure. However, when you run that service, it deploys out nodes. Those nodes are virtual machines, and you pay for those. You pay for the storage, you pay for the compute. So that's how the Azure piece comes in. But the actual management service, which is AKS, right, that piece is free. So if we look into this, and let's jump to our next one here. This is what your architecture looks like. So you can see here that you've got your Azure managed, you've got your control plane, your API server, your scheduler, right? Those are the pieces we don't have to worry about. We only have to worry about these nodes, the kubelets, runtime, containers, your workloads, basically, right? So it gets divided into, right? And those are the main components. Now, the control plane, it's automatically created, configured based on those parameters you put in. And then you don't have to do anything for it, right? There's no cost. There is a VM that's deployed out for that, but you don't pay for it. Azure covers that, okay? And then it does reside in the region where you created it. So make sure you do a little planning for this. Actually, when you deploy this out, you're gonna do a lot of planning, okay? Especially when you get to the networking piece later on. You wanna make sure that your cluster is in the same region as where you're putting your workloads, because you don't wanna have that latency and those transaction costs causing an issue there. Then the control plane includes a couple core components. You've got the API server, okay? And that's how your APIs get exposed. So when you actually run your API, you run in your CI pipeline, it's connecting to the API server, and then it connects over to your nodes, right? It actually hits that scheduler. The scheduler is what talks to the nodes and says, hey, this is what we're gonna do, and we're gonna push this update, this version out to this node, these pods, right? So that's the piece you have to control. And when you're deploying this out, you can limit that. You can actually go in and say, well, you can do this after you deploy it as well. But you go in and say, I only want my API server to accept communication from a specific IP or IP ranges. Okay, that's very important because you're exposing that piece to the internet. Okay, and we don't have a way to put a firewall on that because it's Azure managed. So that one command parameter when you're creating this or after you create it is how you limit that. You put that in, and that puts in this NSG rule, right? That's only going to allow that, but it's on the Azure managed side. So we get a little tiny bit of control, right? So etcd maintains the state configuration, right? It's a key value stored within Kubernetes, right? We don't have to worry about it. It basically makes sure everything stays where it's supposed to be and keeps those configurations. The kube scheduler, right? That's where you create and scale your applications. So when you push that command out, you connect to your API and you push your CI pipeline to put out a new version, it's going to go to the scheduler. The scheduler is going to determine which nodes can run it. Okay. The kube controller manager, it just kind of oversees the controllers and does that management for us. Again, none of this you can touch, right? This is all Azure managed for the control plane. Now, AKS provides that single tenant control plane with the dedicated components on it that we just talked about. You can define the number and the size of nodes, which you're going to need to do. That goes back to the immense amount of planning you need to do when you're doing this. Because for your workload, you need to know what kind of resources are available, and you have to set a large enough node that has enough resources to support the number of pods. Okay. So take that into account. You may not know it at first. You may default stuff out, but trust me, you're going to redeploy a lot. Okay, especially in the beginning when you're getting everything set and you're kind of tweaking everything to get it just right. You're going to end up wanting to do this as code because you're going to want to wipe it out and redeploy it easily. Okay. Now, interactions with the control plane are through APIs, right? One of those is this kubectl or kube control. Okay, that's the command line piece. You have to log in to Azure on command line and then connect to the cluster. And there are permissions that go in each place, right? Everything is layered. Now, the nodes and pods, right? This is what we've been talking about. These nodes, okay? The nodes are a VM, okay? The VM will have pods that it creates, and then the pods will have containers, okay? So when you're doing this, you need to understand how many pods per node, because with that, you're going to say, all these pods require this much resources, right? So if you have 32 gigs of RAM in your VM or your node, right? But then you're going to deploy out 100 pods on this thing, and each one of those pods needs 8 gigs of RAM to run whatever workload they're doing. You are not going to have enough, and you're going to get into a starvation mode in your cluster. Okay, so you really have to plan this out and know how large do you want your nodes, how large do you want your pods, and you need to be aware of what it is you're doing in those pods, what your workloads are. Because you may just want to break it up and say, okay, well, instead of having, all these things happen, let's break these up. And that's where you get into microservices, right? So that may give you a better resource consumption and more control over it. Okay. The virtual networking is handling by this kube proxy on the nodes. And we're going to get into the networking here in a few minutes. That gets a little bit more in depth, and you guessed it, more planning will be in there. So our next piece, this is what it looks like. Okay. You've got your node, which is your Azure virtual machine, and it's going to contain the kubelet, the container runtime, the container, kube proxy, right? So you've got your virtual machine, and you've got your pod here, right? Your pod has the node in it. Then you'll have disks and files and all that stuff. Okay. The pod connects and talks to the node. The container talks to the pod. So everything gets routed through. And then the node will talk to the network. So the VM size of the node determines how many CPUs, how much memory, right? Size, type of storage available. This will get very important very quickly, okay? If you anticipate your applications are going to require large CPU, you may want to rethink how those nodes are, okay? Now, the VM image for the nodes is currently based on Ubuntu Linux or Windows Server 2019. You can do either one. You can do a mix of both, right? But that is going to change how things run, right? Most of these are run in Linux. So Ubuntu, right? Now, they're billed as standard virtual machines, but if you have reservations, right, you can tell it exactly what VM size you want to use. So if you have a reservation, then you can use that size to match the reservation and you can get some discounts on some of this, okay? Now, when you scale out your nodes, so that's another thing you can do, right? You can start with 3 nodes and you can start with 10 pods per node as you do this. But what you need to be aware of is as you do this, you can go in and say, well, when it reaches this point, just scale out, give me more, right? So that we don't impact the application, right? We don't want to have an issue where you're running, everything's great, and then 1,000 people start using your application, and now you're in a starvation, right? You can auto scale this out, or you can manually do it. So we'll get into that a little bit later. So the node pools. You have to have at least one node pool, right? And this node pool will have the number of nodes that you want in it. And those nodes will have the pods per node, okay? Now, you can't change the pods per node after you create the node pool, but you can create a new node pool, okay? And you can keep going. So if you have different applications, you can run them on different node pools, and you can have auto scaling, right? You should always have at least 2 nodes in your default node pool. Otherwise, you're going to run into reliability issues, right? And we'll talk about that a little bit later in this. But what happens is if something happens to that pod and it has to blow it away, if that node just stops working, gets corrupted, whatever, it can be deleted at any point. If you only have one, that means your application is down because you don't have any, and then it has to re-provision. Okay. Pods. Kubernetes uses pods to run the instance of the application. Okay. So one pod is one instance of the application. All right. Now, typically they only have one container. So it's a pod container can be used interchangeably. However, you will get in instances where you may have one pod with multiple containers, right? And when you get into that, it gets very tricky, right? Because you're going to have one node, that one node could have 10 pods, and those 10 pods can each have one or more containers in them running instances of your applications. So those multi-container pods run together on the same node and allow the containers to share resources, right? So that's something you have to be aware of. You need to know where these fall in, what they do. And here we go, a node. Cluster has one or more nodes, which is a VM. It's just a virtual machine with the Kubernetes components and a container runtime on it. The pod is the single instance of your application, and the container runs inside your pods. So that's something you have to look at. All right. Now, containers are where the application workloads actually run. So we've got our nodes, we've got our pods, we've got our containers, but how do we manage that? So one way to manage it is management tools. So you've got kube control or kubectl, which is the command line interface that you're going to use. You've got YAML, which are basically these code files you're going to write. And when you need to do something, you're going to write the manifest file, which is in a YAML, which is a language, right? And you're going to apply it using cube control. Okay. Helm charts is another one. They're a tool for managing, so you can build the Helm chart and then apply the Helm chart, and it'll do a lot of this for you. And then when you get into the stateful applications, they get a little different, right? You may have things that require specific things to stay the same all the time. And that's where you'll get into stateful sets and daemon sets. Okay. I'm going to kind of gloss over those because that's a whole nother topic. Just know that they're there. Okay. Now, the namespaces. Okay. Namespaces, you create them to separate business groups. Okay. So you may have users that only interact with certain resources that are in their namespace. Okay. And this is what it's showing you, right? You may have admin users that have a system namespace that they interact with those. And you may have engineering users that only interact with their engineering namespace. And they'll have a blog service and they've got their pods under them. Okay. It's just a logical way to divide your cluster and restrict and create accesses for people. Now, networking. So networking gets a little bit complicated as you do this, right? Because you've got a couple different options here. So in container-based microservice approach to it, they have to work together to process everything, okay? That means Kubernetes will have various resources that enable that communication, okay? And you have to look at your communication between your containers, your pods, your nodes, but not just that, you also have to communicate outside the cluster, right? Because what good is running an application that's isolated and can't talk to anything, right? So some of the more complex applications will get into ingress traffic for SSL and TLS termination and some custom routing stuff, right? So that's a piece you have to look at. And again, goes back to planning. So for security, you will also have network policies, okay? And that's how you restrict the flow of network traffic between the pods and nodes, okay? And there we go. And of course, I clicked too much. So to allow access to the applications or for the applications and components to talk to each other, Kubernetes has this abstraction layer to the virtual networking, which we're going to look at here in a second. Okay. So the nodes are connected to the virtual network and they provide that inbound, outbound communication for the pods. Okay. So depending on how you do this, some of that will be NATed communication for the network level. And we're going to look at the different models of networking that you can do with this. So services logically group into pods to allow for that direct access via an IP or a DNS name, right? So that makes sense because your pods run on the same node. So if you group your services into the pods and then the pods are grouped into the node and then the node is controlling that communication, you're all going out with the same IP address, right? So you can do that. You can also use a load balancer, which most of the times you're going to want to, okay? You're going to have ingress and egress considerations you have to look for, okay? Oh, and the last line on here is important. Kubernetes network policies. Those are important. If you don't know them, look them up because you're going to have those in place in order to secure and control your communication between your nodes and your nodes and nodes and pods. Yes, I will get this right in a second. So the Azure platform helps to simplify it. And what that means is this is not a simple networking endeavor by any means. Okay, you're going to have load balancers, you're going to have different communication, you've got NATing, you've got rules that go in place, and then you have Azure policies on top of all of it. Okay, so this is not a simple virtual networking. They help to make it as simple as possible. Okay, so let's look at some of this. So the services, to simplify the workloads, they use services to logically group them, okay? The IP address for the load balances and services can be dynamic, or you can specify static, okay? Both internal and external static IP addresses can be assigned. So the existing static IPs are usually tied to a DNS entry, okay? Now, this is going to change a lot based on the type of cluster you do, okay? Because there's several types. Well, there's two types. There's a public and a private. If you do a private cluster, you cannot talk to anything, okay? There's ways around that. That's a whole different video we'll do. But with a public cluster, you're open, right? You're just open to the internet, anybody can come connect. And that's why those network policies and security considerations come in. Extremely important in a public cluster. A private cluster means you're taking it a step beyond what those policies would be. And you're really controlling, okay, you can only connect from this specific IP range to do anything. So when you get into third-party CI tools and pipelines, that's where that'll come into play. So networking services, you've got a cluster IP, you've got a node port, and you've got your load balancer. Okay, and these are kind of examples, and yeah, it's a lot of information on the slide. I understand that. Okay, but you look at this, you'll have your internal traffic, it's your cluster IP, and it'll go over to port 80 on your pods, right? This is just an example. You can change all this stuff, right? This is only good for internal only applications. So if you're running something and it's only going to talk to your own network, okay? Custom applications for internal use, basically. Now, the node ports creates this port mapping for the underlying nodes so they can be accessed directly with the node IP. Again, this will change based on the type of networking you're. Now, the load balancer, this is where you get all kinds of tricky. You're going to have a back-end pool that has these nodes. You're going to have a front-end pool that's going to have the specific IPs. And when your traffic hits specific IPs and ports, then it's going to divide it out based on the criteria you give it to this back-end pool, which then sends it to the pods. Okay. Now, virtual networks. There's two types. Okay. When you do your cluster, you have to pick Kubenet networking. Basically, everything gets NAT. Okay. So you can have this ginormous range. You're going to have, you know, a /8. Okay. So you can have all of these IP ranges out there, and it doesn't matter if they overlap. Nobody cares because it's all NAT. Now, when you get into CNI, the container networking interface, it's more of a flat network. Nothing can overlap. And you really have to base this out on how you're going to do your pods. It takes a lot more planning, but you do get some more advanced security features that you can do. Okay, so let's look at some of this. So Kubenet. Okay, it's a networking option. It's the default for cluster creation. You can deploy a cluster, tell it Kubenet, throw some IPs in there, and you're good to go. Okay, so the pods receive the IP from a logically different address space. Okay, nodes get the IP addresses from the virtual network, and then pods get whatever they need to get. Okay, it uses natting, so you're only talking to the nodes, and then the nodes are natting that, talking to the pods. Okay, the source IP address for the traffic is always the node's primary IP address. Okay, and then the nodes use the Kubenet plugin. Okay, you can let Azure take care of all this. It's super easy. You don't have to worry about a whole lot. Less planning for you. You never have to worry about space. Well, unless you go over like 65 million addresses or something, right? So that's Kubenet. Now CNI, every pod gets an IP address from the subnet that it's on directly. So you got to plan your subnets and your VNets, and you can't overlap with anything you're going to be talking to. So if you're running connections to on-prem over ExpressRoute or VPNs or anything like that. You've got to make sure this is straight. Okay, and you have to identify and give specific CIDRs to that. Okay, but this means you can directly access a pod. Okay, you don't have to go through the node. It will, but you can put in the pod IP address and then it will talk to it directly. Okay, so a lot more goes into this. So here is our CNI networking. Okay, you see you've got your virtual network, and then it connects to a bridge, and then it connects over to the pod. Okay, so you can talk to straight across. Okay, so it's more of a flat. So there's tons that go into both of these, but let's look at some of the high points on them. So Kubenet, you can serve your IP address space because you're natted. You don't care what they are, right? So you're using internal and external load balancers to reach the pods, and you have to manually manage and maintain UDRs, okay? And you get a max 400 nodes a cluster, right? Now with CNI, you get full network connectivity across the board, requires way more IP address space, tons more planning go into it, okay? So if you're looking at this and you need to be able to communicate or you need to route things, you really have to do a deep dive into each of these and determine what's going to be best for your network. Ingress controllers. So incoming traffic, ingress. Okay, you'll have ingress controllers that go in place, and that's where you have to map things. Okay, your load balancers only work at layer 4. The service doesn't actually know what's going on. Okay, all it knows is this came in. Now, ingress controllers work at layer 7, and they can use more intelligent rules to distribute this application traffic. So that's where you get the ability to route HTTP traffic one way. So you may have things, different protocols going different places. Okay, and a lot of times what people use is called an Nginx ingress controller, which is a service you can push out. Right, if you get into that, then that's more in depth on how you're going to do it, how you're going to plan it, and what your workloads are doing. Okay. Now after that, everybody loves network security groups, right? So network security groups filter that traffic from the VMs, right? It gives you that east-west control for your network security, but you don't ever want to touch these, okay? They're going to get created. You don't want to touch them. If you need to do something with this, then you need to define those ports in your YAML manifest and let the Azure platform create those rules, okay? Otherwise, you can mess up a lot of stuff, and if it's not in the manifest, when that gets blown away, it may just wipe them out, and then you won't know what's wrong, and you'll have to go figure it out. Network policies is the next step. Network policies are talking about pods talking with nodes, how that traffic routes, okay? So this is one that you need to look at. The network security groups are for the nodes, and the network policies are for the pods. Storage options. This is a fun one. So you may have instances where you need an application that's going to connect to a storage account or Azure Files, blob storage to store whatever data you need to do. Okay, there's a lot of options here. Okay, sometimes you need local fast, and then it's no longer needed. So what can happen is if you pick the wrong storage, when that pod gets blown away and recreated, that may wipe out your storage. So you have to look at how you want to do these. And multiple pods can use the same one. So that's where you get into the different volumes, okay? So typically it's going to treat the individual pods as ephemeral, right? They're disposable, you can wipe them out, whatever, okay? The volume represents a way to store, retrieve, and persist that data across the different pods through your application lifecycle. So, and the volumes, of course, are more than just a traditional disk, okay? Because you're putting this stuff into storage accounts. So those volumes can be a way to inject the data. They can also be a way to just store information needed, write your log files, things like that, right? But you may also want to take that data and have it out there. And when you build a new pod, just inject that directly. And we will learn how to do this PowerPoint thing. All right, storage volumes. This is a little small, so bear with me. Traditional volumes store and retrieve the data, and they're backed by Azure Storage. Okay, you can manually create them. You can have the pods do it directly. You can have the AKS service do it. Okay, so there's a couple different types. Azure disks are used to create the data disk resources on the nodes. Obviously, it's a VM. It has to have disks in order to have the OS. Right? So you can set them up to use premium, standard, SSDs, HDDs. Right? But whenever you're doing this, most production development workloads are going to use premium storage. And they're mounted as a read-write once. So they're only available to a single pod. Okay. Storage volumes that can access multiple pods are actually Azure files, not disks. Okay. So Azure files mounts them with an SMB 3.0 share backend, just like you would if you're accessing it. Right. And it lets you share them across multiples. Okay. So more like a file server in a traditional setting. All right. And of course, you can use standard premium SSD, HDD. Okay. Now, there's a couple additional volume types for Kubernetes. There's an empty dir, which is just your temp drive, right? Then you've got secrets where it can actually write things to it to store it, and it marks it so only certain pods can actually access it, and when it's no longer needed, it's wiped out. Okay. The other option here, which I would prefer, would be a key vault. Config mapping is used for the inject key value pair properties into pods. So like the secrets, it gets wiped out eventually, right? But you can define it to pods or deployments, right? And they're only available within a given namespace. Persistent volumes. This is where you're going to write data and you need it to stay there even after the pod's gone, okay? So when you're looking at this, just identify what the needs of your application are. Right? There's a lot of questions, a lot of planning that go into this, and that cannot be overemphasized. Okay. And when you look at this, there's ways you can do this, right? So you can allow the persistent volume to be created by the cluster. You can do it dynamically through the API. You can manually create it and attach it if you want, if you like having more work. But this is all designed around automation. So if the pod's scheduled and the request storage is not currently available, Kubernetes will create it, okay, and attach it. Dynamic provisioning uses a storage class to identify the type, okay? So let's get into storage classes. So to define the different tiers, premium, standard, you can create a storage class, and then you can define that storage class. Okay, it also defines the reclaim policy. And then when you're doing your manifest, you're doing your code for all this, you can specify that storage class. Okay. If you don't, it's going to use a default. Okay. So there's 4 initials storage classes that are created. Okay. There's a default, which is a standard SSD storage, creates a managed disk. Okay, you've got managed premium, you've got Azure File, you've got Azure File Premium. Okay, those are the basic ones. You can define further if you need to create more. For clusters that are using the new container storage interface, this is still in preview, right? There's a couple others, managed CSI Premium, Azure File CSI, Azure File CSI Premium. My personal thought on this is Microsoft wanted to be able to say CSI, okay? But there are different options here. You can look at them, you can define your own. If there is no storage class specified, the default storage class is used. So make sure you know what you're putting in your code, what you need, and check this to make sure that you're using the right storage class. Because if you need it to be a certain type and you don't put it in there and it defaults, that could cause you a lot of problems. Persistent volume claims. So this is how you request either the disk, the file storage, particular storage class, access mode types, okay? The API server dynamically provisions the underlying storage. And if you don't tell it, right, it's gonna default to the default storage class. And if there's not a resource there and you say you need one, it will build it, right? If you build it, they will come. Kubernetes is all about this. You just tell it what you need, it figures it out, it builds it for you, okay? Now, this is what it looks like, okay? You'll have your storage that's outside the cluster, okay? Because storage accounts exist in the tenant, but they're not tied to any specific thing. They're just attached, okay? So you can blow away the VM, your storage is still there. Now, it's usually a one-to-one mapping for persistent volumes to the claims, okay? Just be aware. I mean, the big takeaway on this is gonna be know what your application needs. If there are specific requirements, define those in your code. Otherwise, you're gonna run into problems and you'll have latency, you'll have disk write issues. And if you're doing this on an HDD standard, right, and you need this to be on a premium storage SSD, you'll have to go and hunt this down and find it. And typically it's gonna be, the devs are writing the code for this. And then if the stuff is not specified and things are not planned, then your infrastructure guy is going to have to go and hunt this down and track it and be able to find and identify this stuff. So it really has to be a collaborative effort, right? Your devs have to identify what it is they need, work with your infrastructure people to be able to say, okay, this is what we need, and this is how we get it, and this is how we make sure it stays, right? Scaling options. So one of the good things with AKS is you can set it and say, okay, well, I need 2 right now, but I might need 10 later, right? So you can start with a small number of nodes, and then you can just tell it, okay, well, once we get there, let's scale out, right? But it's not just nodes, it's also pods, okay? And you can do this manually, you can do it automatically, right? So the horizontal pod autoscaler is what it's going to use. It monitors it and then will automatically scale the number of replicas you have. Okay. So say you've got 3 nodes, you've got a pod per node, and then something happens and you need to say, well, I want more pods. I need more pods to be able to do this. Okay. It'll check every 30 seconds or so, and then it can scale out for you. It can also scale back in, right? But there's cooldowns of the events that go in. Now, you have to make sure that you're running the right versions of the cluster in order for this. But unless you're running a very old version, you should be fine, okay? The horizontal pod autoscaler works with clusters that have deployed the metric server on Kubernetes 1.8 or better. Right? The last one I saw was like 1.18. Okay. Now, when you do this, you just have to identify, like, what do you need, and then think ahead, right? Assume you're going to have more people using this, and what's your process going to be there? Again, more planning. So the scaling options, cooldown of the events, okay? It's going to check the metrics API every 30 seconds, okay? Now you're going to have timeouts, and you can't really tune these, right? You can't change them from the defaults, okay? But it sets a delay, right? And you'll want to look at this to make sure you understand what those are, okay? And you want to know when it's going to scale out, when it's going to scale up, and when it's going to scale in and down, okay? Now, the cluster autoscaler is a little bit different, right? It's going to respond to the changing demands for the pods, and Kubernetes will be able to look at that and say, well, how many nodes are requested, right? It's also going to check the metrics API server. Now, for the cluster autoscaler, you have to have RBAC enabled, and you have to be running version 1.10 or better, okay? It will check this every 10 seconds or so for the nodes, okay? And then it will scale the nodes. So as we look at this, right, this is the cluster autoscaler. This is going to scale out the nodes, and then the horizontal pod autoscaler is going to scale the pods, okay? And then they work together, right? When combined, they'll increase or decrease based on the application demand, which is why people use Kubernetes. Now, it's typically used, the cluster autoscaler is typically used with the horizontal, right? Because it allows that working together, okay? For scale out events, if you're looking at scale out, right, it determines the node does not have sufficient compute resources to run a requested pod. The pod can't progress through the scheduling process, right? Remember that scheduler in the control plane? Well, if there's not enough resources, then that kind of gets stuck, right? So what this does is it'll scale out and say, okay, well, you need more nodes. So you have more resources, right? Because it can't change the size. It can only change the number of nodes, okay? So it'll just deploy out another one. That node will have additional pods, and then your scheduler can reschedule that to go on the new pods. The scale in events basically works the opposite, right? There'll be a threshold. If it determines it's no longer needed for more than 10 minutes, then it's going to start collapsing, right? So as your application needs more, it'll scale out. That'll make your prices go up because you've got more virtual machine instances out there. But then as it's the need for that application goes down, it'll scale back in, and then your prices will come back down. So you'll get this even out, right? Because during the day, it might need a lot, it'll scale out, right? You'll have a high price, but then at night, if nobody's using it, it'll scale back down, and you'll scale in, and then you'll reduce those. So you'll get a balance, and it will actually help you save money. Now, one thing, if we go back, one thing to remember here, to minimize your disruption, do not have a single pod instance, right? Don't have an application that runs on just one pod, okay? Because what happens when that one goes down or has to change, okay? Then your application will be down. Now, if you need to burst this up, right? So say you come in one day and all of a sudden at 11 o'clock, everybody starts using it, right? You normally have, 300 people accessing your application, and all of a sudden somebody heard about it this went viral all over the internet. Now you've got all these people coming in. Say you've got 1,000, 2,000, 3,000, right? You're going to want this to burst up to rapid scale, okay? And you can do that with container instances, okay? It has the built-in components, and then it's just going to extend your cluster, basically, okay? The container instances operate outside your cluster, but then once they connect, they kind of fall in, okay? So ACI lets you quickly deploy without the additional infrastructure overhead, okay? You just connect the AKS to the ACI, and you like using 3-letter acronyms, and it becomes a secured logical extension, okay? And you'll see your cluster, and then you've got your ACI off to the right. You do the rapid burst, you get pods over there, right? Now, one of the things people like for AKS, Kubernetes in general, right, is the idea that you have this cluster, and you've got these nodes, and it scales out and in and all that stuff, right? Then you've got pods that connect to those nodes. Then you've got containers that run on those pods. But what'll happen, and this happens all the time, right? You'll have a bug in the code and it's going to corrupt this pod, okay? Or you're going to have this pod just stops working, stops responding, you make a change, whatever, right? What can happen is the AKS, the Kubernetes service, is going to go in and say, well, I didn't get a health check for you for 10 minutes, so I'm just going to delete you, right? It'll wipe out that pod, it'll deploy a new one. Now, the VMs, the nodes, and the pods are going to work together to make sure your application stays up, okay? It's going to deploy out a new pod, running that workload with containers, so you don't have to worry about that, right? But this is the auto repair, right? And it can do it with pods, it can do it with nodes. Pods get wiped out all the time, nodes not as much, but if it does happen, if one stops responding for some reason, if it becomes unhealthy, it'll just get rid of it and build a new one, right? And that's kind of what this is for. That's why you have AKS. So that is the end of it, and you can't ask any questions because this is a video. But you can leave comments, you can send me messages, you can let me know, send me a carrier pigeon, right? I hope it's been helpful, and I hope you didn't get too bored in this very long presentation. So come check out our website, watch for new articles that we're going to be doing, and come back and see us.